Arithmetic sequences. What's the D stand for?
Difference.
Common difference. Good, 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 good. How do you see it in a pattern? But what about the certain amount? There is a certain constant amount that's repeated over and over again, but what's going on as you go from one term to the next? Adding, or it could be subtracting, which is adding a negative, which is what number 14 is. What does this A sub n stand for? All about terminology right now, Denise. Pay attention, kiddo. What's A sub n stand for? N term, right? And later when we get to it, what does S sub n stand for? S stands for sum. And S sub n is the partial sum. Sum of the first n terms. All right, number 14. Final answer is a It is arithmetic because D is equal to -3. Number 40, your first 5 terms, 190, 80, 70, and 60. Oops, I forgot. I apologize. 200 was the first, but they gave that to you. Number 48, final answer, once you plug in for the 7th partial sum into the formula that we were hopefully getting good at yesterday, 70. Sum of the first 7 terms, shortcutted with the formula 70. Number 54, final answer, is 4,600, but did they give you the 50th? Did they give you the 50th term, or did you have to go find it? But how did you? Using the formula, right? Using the A sub n formula. So they found I think this should be, is that right? I apologize for that though. That's better. So they found A sub 50 to be 190, then they were able to plug in and find the 50th partial sum. All right, number 66, have you guys already figured out that it was D as in delta, and number 68, A as in alpha? Are there any places we got stuck? Odds or equals? Scroll up just a little bit. Arithmetic, we're like, got that quiz today, we'd ace it? Minus the whole memorizing the formulas thing above.
Yeah, that's true.
Struggle. Ricky, stop eating here. Ready, set, and? Alright, here we go. Let's go find some geometric. We got to start geometric yesterday. We didn't get to finish it yesterday, so I'm pulling it back up. We did not finish a tricky example, but I did show you 2 different ways to solve it. We did not get to finish this tricky example, but I did show you 2 different ways to solve it. So my question to you is, can you finish one of the 2 ways? Now hold on, first of all. Can someone at least help us, what am I trying to say? Identify the 2 ways. What are the 2 ways I have up here? I can separate them with a little gray line. What are the 2 different ways of solving? Okay, elimination, setting up a system of equations, and what's the other one?
Do the math.
Think of the puzzle. On the left is, think of it as a system. You have an A sub n formula. You can plug in A sub 2. Plug in 2 for n so they equal to what it actually is from the top. A sub 5, I can plug in 5 for the formula so that it equals to what it actually is from the top. The left says plug into formulas and hopefully there's a math way to solve once you have a system, and there is. The other way says there's a pattern. If you know it's geometric, you know there's a certain way that you progress from one term to the other in the pattern. Let me give you guys, I don't know, what do you think? 2 minutes? A minute and a half? Pick a way. Either pick the solve the system way and say, okay, hold on, I'll maybe solve for A1, substitute, see if I can get to what I need, which is finding A sub 1. Your end goal is finding A sub 1, but if you find R, that'll help, right? Does your brain work more in the system, or does your brain work better in the puzzle? Nathan. Ooh, go fast and change it. Oh, I plugged in too quickly. Wait, Tyler found a typo. Righto. A mistake-o. Never mind. N minus 1 should be the formula. Make sure if you're using the system, you take advantage of the mistake he found. Ooh, how did I was looking? I'm going to freeze the screen for just a second. I'm not sure if we'll get done quite as early as I would hope today. But if we do, there's something really cool I'd love to show you. If I don't show you today, though, I'll show you really quickly tomorrow. Hey guys, real quick, what section are we in? 3. From the homework page, those of you guys that have paid attention, what section are we skipping?
4.
And then question, when do we have a quest, which will basically kind of be like a test?
Friday.
After 5. Check out the calendar. I think I have it as next Tuesday right now, so we're going to need today for 9-3, tomorrow and Friday for 9-5. But just a quick heads up, we are having a 9-1, 9-2, 9-3, 9-5 quest to come in. It's going to count probably like 3/4 of the test. Because then there's a probability quiz for the last 2 sections of 9, and then we'll go on to chapter 10. Just giving you a heads up. So what should you be doing with these formulas that are highlighted in these sections, kiddos? Ooh, making formula cards. I'm giving you the weekend. And then I'm not giving it to you Monday, I'm giving it to you Tuesday. So you have some time to get those formulas down, but just make sure we're working on them. Whatever you're using in homework, you're going to have mentally stored for the quiz or the test. Does that make sense?
You can't bring a formula card.
You could, but it would be called cheating.
Bad.
But you could make a formula card. Alright, real quick, talk in groups, because you might have solved it 2 different ways. Let's see if we were able to first find R, if you were doing the system, but then if you were eventually able to find A1, or if you were able to solve the puzzle. Oh, come on, I don't hear talking in
Help
groups.
everyone explore new worlds and ideas. Support your PBS.
Nailed it. My group and I agree.
Yeah? On the answer or the non-answer?
Yeah.
You're the only person in your group.
Yes.
Well, there technically is one back
I
there.
agree.
Alright, here we go. My system people. How did you start to solve your 2 equations? And hopefully you noticed that these were the 2 parts of the equations you should probably solve. How did you guys go or proceed?
Subtract the one.
No, not subtract, it's being multiplied.
Multiply by negative 1 on top of.
I'm not sure I would do that.
No?
I'm going to rewrite it real quick. Because we can't do elimination because they're not like terms, right? Isn't one r to the 1 and the other one r to the 4? But how can we proceed solving the system of equations? Come on, cool kids. We can't substitute yet, though. What would we have to do first?
Divide by A1. Just think.
Yeah, we could divide by A1 or we could divide by R. Which one did anybody do?
Divide by A1.
Okay. So then dividing by A1, we get R is equal to 3 over A sub 1. What are we going to do with that 3 over A sub 1? Plug it in, plug it in. Then to solve that system, we could go ahead and say A sub 1 times 3 over A sub 1, all raised to the, what's R being raised to? The 4th power, equals 3 over 64. We have A sub 1, 3 to the 4th. Wait, what is 3 to the 4th? Someone had to find that. 3 squared times 3 squared, or 9 times 9, there we go. We'll have 81, a to the 1 over a to the 1 to the 4th power. How can I reduce those a to the 1s? Yeah, I can simplify, right? I can reduce. So I'm going to have 81 all over a sub 1 cubed equals 3 over 64. Probably a lot of you guys would think of cross multiplying. At which point you would get, does 3 and 64 reduce? No, it doesn't. That's a bummer. So we would get 3 a sub 1 cubed equals 81 times 64. I'm just going to do this because I'm a cheater. So I'm going to divide by 3 in a second anyway. That's going to be 1 and 27. When you finish, a sub 1 is equal to the cubed root of 27 times 64. Was that a nice answer?
Yeah. No.
I don't know. In your calculators, we can find it fast. What's 27 times 64 and then cube rooted? Hey, the cubed root of 27 is 3. The cubed root of 64 is 4. 3 cubed, 4 cubed. Isn't that just going to be 12? Did anybody check me by actually doing the math? No? Nathan's plugging it in quick. So here's the question. Did solving the system work?
Yeah.
Just give me a yes, it works whenever anyone plugs it in.
Yeah.
Cool. But, my puzzlers, did you figure out, like, I don't know. I would call it more of an SAT approach. You guys know in the SAT, if you take a lead or if you take any other SAT prep, they're usually trying to teach you tricks to go fast, right?
Yeah.
They would probably want you thinking about it more as a puzzle on the right-hand side. And if it's a geometric sequence, wouldn't you have to multiply by r how many times to get from 3 over 64? Mm-hmm. So you could set up your own little equation without just plugging in and say that 3 times r cubed is equal to 3 over 64. Does that make sense? Because to get from a sub 2, the second term, to the 5th term, there's 3 jumps in there. Then we divide by 3. You would end up with r cubed is equal to 1 over 64. And if you cube root both sides, that leads you to r is equal to 1/4. So if you're multiplying by 1/4, and if we want to find a sub 1, puzzlers, how do I go backwards? Multiply by 4, multiply by the reciprocal. If we go back, remember we're dividing, so we flip it. If we go forward, it would be times 1/4, but backwards would be times 4. So question, what would have been divided by 4 to get 3? Both ways work. One way requires a much more puzzling, maybe that's not the right way, a much more logical approach, and the other one requires a much more systematic approach of knowing formulas, plugging in, and hoping that somehow it'll work out with like a system. Does that kind of make sense, kiddos, the difference? Nathan?
Why does it go to 1 over 64 instead of dividing the 64?
Oh, remember if you divide by 3, it's like multiplying by 1/3. So if I multiply by 1/3, it just makes it a little bit easier to do the math quick. Or I should say quickly. So we went backwards 1 jump, which would be times the reciprocal, or times 4. Kind of, sort of. This is probably the most complicated type of problem if they're talking about finding a term. They've given you not the first, not the ratio, but other random information that you have to somehow put together. But once again, there are 2 approaches. One is a much more logical, that's the right, and one is a much more systematic using the formulas, that's the left. Okay, talked about sequences, but we did not get to series. Let me just give you guys a couple moments to get down. There we go. To get down to S sub n formula for geometric. If you think about it, arithmetic had an a sub n and an s sub n. Geometric has an a sub n and an s sub n. Arithmetic has d's involved. Geometric has r's involved, just based on the nature of the sequence. Or in this case, S sub n of the series. Yes, happy Wednesday, guys. Does anybody have section 9.3 homework written down yet? Some did. Nadia, did I assign number 91 to you guys? I did? Good. Just checking.
Would this be not calculator stuff?
This one would probably be a calculator problem. And some of you are really excited as a result. Don't worry, I'll show everyone. That way you're not like cheating and they're just doing it the hard way. However, there are ones that are similar but a little bit easier that could be a non-calculator one. Does that make sense? Okay. All right, kiddos. S sub n. Nth partial sum. What does that Greek letter stand for again? The one that's being hidden by my poor little calculator? Oh, okay, it means summation, but what Greek letter is it?
Sigma.
Sigma. Okay. What does a sigma denote? That was your second answer, summation. Okay. So we have sigma notation denoting or showing summation. If I was to actually write out what this means, wouldn't I have to start plugging in stuff? Where would I start plugging in? Have we realized where to start the lower bound, right? And we count up to what again? When do we stop plugging in? 1, 2, 3, 4.
12.
Yeah, stop at 12. I'm not going to do all of that, right? That'd be kind of ridiculous. But 4 times 0.3, if I plug in 1, what's 1 minus 1? Plus 4 times 0.3 to the 2 minus 1. Hopefully pretty soon you can see a pattern. 3 minus 1 would be 2. And when am I going to stop? 12 minus 1.
11.
Does that make sense? You plug in the 12 minus 1, and it'd be the 11. Okay, good, but stop when you plug in 12. Could we type that all out in our calculator and keep going between 2 and 11? Sure. That sound kind of annoying a little bit. If we were to simplify this, we would technically have 4, because anything to the 0 power is 1. Plus, the next one we would have 4 times 0.3, or 3/10, plus 4 times 0.3 squared, or 9/100, plus ... And then, I don't even want to think about that one, I'll just say 3 times to the 11. That's why this one is a calculator problem. You wouldn't be expected to raise that power. But there is an easier way to find the sum, and the easier way is the formula up above. So, what would I put as my n in the formula?
12.
Equals. Now, kiddos, this middle part does tell us how to sometimes see a geometric series, but a quick word to the wise, not every geometric series is always written exactly like that. There are lots of ways to show these things. That's just one example. So that's a good example, but I'm going to actually put that real quick in parentheses, just to say like, that's good. But if you really, really, really need to see how to plug into the formula, if I were you, I would look at the actual sequence itself and say, hey, who's the first term? That guy? Sure, but who is that? 4. Plug in the first term. 1 minus, who's your R, or your common ratio? We'll check it out. 4 times who to get to the next term? 3/10, right? 0.3. And then times what to get to the next term? 3/10 again, or 0.3 again. So we could do 1 minus 0.3 or 3/10 raised to the, who's n again?
12.
12. All over 1 minus 0.3. Now, let me show you why, once again, this would be a calculator problem. If they wanted you to find a final answer, am I going to expect you to do that to the 12th hour? By hand? Definitely not. So this would be a calculator problem. And you would plug and chug, and you would go ahead and be able to solve. However, what did we already talk about last section is hidden in your math up a little ways.
A summation.
A summation. So couldn't you technically, if you were given this, couldn't you just plug it in your summation?
Yeah, but I got.
Yeah.
So it's,
The only dilemma is, what if you're not given a summation? What if you're just given a series and you have to figure out the clues and you don't know what the summation formula would look like? That's when maybe you would need this formula, even if you could use your calculator. So, whether you're using right now your calculator the summation one and just plugging and chugging, or whether you're plugging in the formula, should end up at the exact same answer. And who has found that for me yet?
5.714282.
Okay, so we'll just go ahead and round to 5.714 rounded, right? Next one's 2. So you could have used your sigma notation, you could have used your summation, or you could have also used the formula. Either way works. So let's go ahead and go to a couple more examples and ask ourselves the question, could we have done any of them by hand? First question. And then, can we always use the summation notation? Is it always easiest? Okay, let's see one. Could we use the summation notation? That was one question. Yeah, they gave it summation notation. So we could use our calculator to do that. But is it written, as you guys are writing it down, is it written the exact same way as the one that was
Yes.
in the box?
With a 1 in front.
Oh, okay, so we could see it as being a 1 in front. Or if that's a little hard for you guys, couldn't you have also actually plugged in when n is 1, you get 3 halves to the 0? Plus when n is 2, you get 3 halves to the 1. What's the first term? Anything to the 0 power is 1. So you could look at the actual sequence when you multiply it out, or you could realize there is an understood 1 in front. So you could memorize that sigma notation from the box. That's just something else to memorize. I'm not sure if that's a good idea. It might be a little bit easier to actually kind of start the sequence and start plugging in, and then check it out and say who's the first term. And that's just kind of get you guys ready for BC, because in BC, if you ever get there, like it could be high school, it could be college, Calc 2, if you're doing anything engineering, computer science, maybe even physics, medical, sometimes as you go to Calc 2 for certain med schools. Anyway, coming back. Sometimes it's nicer just to kind of write it out and see it for yourself and not just see it in this whole notation with the Greek letter, blah, blah, blah. Long story short, S sub who? How do you know 10? Upper bound, good. Who's my A sub 1? 1. Why do you see it here, or why do you see it here? Both ways work. What goes inside that formula in the box?
1
Who's R?
3 halves.
You see it? It's like 3 halves, another 3 halves, another 3 halves, another 3 halves. Good. So we can do 1 minus 3 halves to the power of?
9. No, it would be 10.
Yeah, b to the n. That's an easy mistake though, because a lot of the other formulas have n minus 1. And what would be on the bottom? Now, can we look at their calculators really quickly? Just because I want to make sure you guys are doing this in a way where you're not letting your calculator mess you up. When you go to put this in, I need to change a few things. No, that's good. If you were plugging into your calculator the formula, which I know. Some of you are like, I could use my sigma notation, whatever. If you were going to plug in the formula, what would be a wise way to plug this into the formula? Lots of parentheses, but I would also use your alpha y equals fraction trick, right? Wouldn't that help you organize stuff just a little bit better? I would say so. Out in the right, you could go ahead and do 1 times. Like if it was a number other than 1, you would put that out there, your a sub 1. Don't I technically, though, need to be careful when I do 3 divided by 2 to the 10th? Is my calculator going to solve this correctly?
No.
No. Because PEMDAS, it's going to say, oh, who to the 10th? There are no parentheses, 2 to the 10th, and 3 divided by that. It's going to be wrong. You have to let your calculator know who you're raising to the 10th power. So PEMDAS wouldn't work in that case. You would need to insert parentheses and say, I need 3/2 that entire quantity raised to the, can I just put it in? Yeah. Raised to the 10th. Does that make sense? You could put big old parentheses out along the whole thing, but since you have this big old fraction, your calculator knows to have this be a separate quantity. Then you could do your 1 minus 3 divided by 2. Question, why is it okay to not put parentheses on the bottom, but it's necessary on the top?
Because they're raising it to the power of 1.
This one, the exponent would have gotten messed up. Down here, though, PEMDAS would do what first? The subtraction or the division?
Division.
Good. So it's going to divide and then subtract, which is what I needed to do. Okay. Then, plug and chug, dun 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 dun. Not by hand because it's to the 10th power. That's gross. Final answer, 113.33. You guys agree? Did I plug it in okay?
Yeah.
Some of you are still on the whole, like, forget the formula. I can just use sigma until maybe you get to number 72.
You have to do
You can either memorize the sigma thing to put it into the sigma and then use your calculator, or just use the formula. The first term is 32. What else do we know? Ooh, what is R? That's hard. Subtracting by 8 and then subtracting by 6 and then subtracting. Oh, it's not arithmetic.
It's like
How do we find? We ask ourselves, what is the ratio and are they all equal, right? Are they equal? Let's look at them separately. 24 divided by 32, the second minus the first, the third over the second. What do these reduce to be? Well, 8 goes into 24 3 times and 4 times, right? Oh, 6 goes into 18 3 times and 6 goes into 24. Is there a common ratio? Was it easy to see? 3/4 is gross. However, there is a common ratio. You just have to go looking for it. Remember, that's why it's called a ratio. One term divided by the previous. If it ends up being the same for all the groupings of terms, there's a common ratio. Awesome. Maybe, but do you realize that we have no idea how many jumps it took to get there? So then that's the struggle. We're like, But it might be easier at this point because at this point, we can plug into our formula all well and good, except we're going to get stuck in one specific place. S sub who? You stop here. Cool. Well, what term is that? Yeah, we don't know. So we could plug in S sub n is equal to a sub 132 times 1 minus 3/4 to the n, which, we don't know, all over 1 minus 3/4. But we can't solve this until we figure out when to end. And we don't know when to end until we figure out who is 10.125. And when does he occur? Why am I going to say you should think about the a sub n formula? Why? I have the term, I have some stuff, and I just need to figure out who is his n. Does that make sense? I know the term, I know 10.125. Who is his n? Well, I got to plug into that a sub n formula earlier in the notes. And that a sub n formula says take a sub 1, multiply it by r to the, here's n minus 1. Oh. How do I solve for n? He's in the power. You might not know the entire way, but how do you start solving the equation?
Divide by long.
Yeah. Divide by 32. We divide both sides by 32. 10.125 divided by 32. Anybody have that? Is that rounded? Can you go to math and then fraction and see if it's anybody prettier as a fraction? Ooh, okay. Let's use that just because it's perfect. Does that make sense? 81 over 256 equals, and then the 32's cancel. So I have 3 over 4 to the n minus 1. Some of you might actually be able to figure this out just by saying, hey, 3 raised to a power needs to end up being 81. Sounds like the fourth to me, right? So we could kind of do that old-fashioned. You guys remember this from algebra? Maybe you do, maybe you don't. If we can make the bases, actually this is Precalc too. If we can make the bases match, '81 is 3 to the 4th, 256 is 4 to the 4th. Oh, wait a minute, can't we then go ahead and say this is 3/4 to the 4th?
Yes.
Hey, couldn't we just cheat a little bit? And not use, what would be the mathematical way of solving for n? You would have to use ln. Should we get you to the same answer in the question, the answer is yes. We could have done ln, bring down the n minus 1. But if it's something as nice as this, we can say, oh, sweet. 4 equals, remember, the bases? The one-to-one property? Yeah, we like these. So who's n? Oh, add the 1. Got it. Careful. So what are we going to do in order to be able to solve? We're going to take our S of n formula that we had so nicely set up and say, oh, I thank you. N equals 5. Let's go ahead and plug and chug. Let's erase the n and say we know what it is, and it's to the 5th. 5 and 5. Could you do this by hand? It'd be hard. Since it's 3/4 to the 5th power, it'd be hard. If the 4th power is 81, we'd have to go another one, which would be 243. 4 to the 4th is 256. We'd have to go even higher. But if you plug and chug it to your calculator, what do you guys get? 781 over 8. Let's get it back up to that answer.
Please.
Try fraction.
Yes. That should be right. Yeah, I think that's right.
Yeah, it's right.
It is.
Oh, yeah. Okay, good. I second guessed myself. I thought it was a different answer for a second.
This summation is so much easier though.
Huh?
Just the summation of
Hold on, Tyler's saying summation's easier. Tyler, how
It's
come
so
we've
much
done this with summation?
You do 5 on top because it's 5 jumps to get there. And then you do x equals 1, and then you just put it into the formula. So it's 32 times 3/4 to the x minus 1.
Is this going to give us the exact same answer? Yeah. But what would you have to know in order to get this sequence, this series, there's addition, right, into that? You would need to memorize the whole box. Does that make sense? So it's up to you. Do you have to memorize the whole box? No. Could you memorize the whole box? Yes. Jane, is that a question? Oh, you're just checking. I was just double checking. Okay. Okay, a couple more seconds on this one. We have one more big idea. The last big idea in section 9.3. And it has us going to infinity. Can you go beyond? That's a good question. Only Buzz can?
You can just do infinity plus 1 and then you've gone beyond that.
True, or is that just another level of infinity?
You know,
Okay,
that is
so
beyond infinity.
finding the infinite sum. We talked about this just a little itty bitty bit in the arithmetic series. We talked about for arithmetic series, if you just keep adding the same number over and over and over and over and over, all arithmetic series will always, do you remember that keyword I used? If the sum is infinite,
Convergent. Divergent.
divergent. Convergent, think of it as getting closer and closer and closer to a numeric answer, to an actual number. Arithmetic series, if I was to write up a few of them up here, I should probably erase all this now. As you guys are writing down the information on the screen, let me actually go ahead and I won't zoom out quite yet. That's the arithmetic. We could do some other arithmetic.
Basically, if you were to graph that, would it look an exponential thing?
Geometric, yes. Arithmetic, no. Arithmetic would be linear because it's a constant rate of change. Does that make sense? What's number one sum going to be? These are all arithmetic, now geometric. What's the infinite sum of number one? What's your common difference? You're going to keep on adding bigger and bigger and bigger and bigger and bigger terms. What's that going to equal at the end? Which doesn't have an end, but what's going to be happening as you keep adding more? It goes to infinity. Positive infinity. Which is why we call it divergent. Number two, what's going to be the infinite sum? 20 plus 15 plus 10 plus 5 plus 0 plus negative 5. Negative infinity. Even though there's a few positive terms, yeah, what's going to win as you go to negative infinity? Well, as you keep on adding more and more negative, bigger and bigger negative numbers, negative infinity. Divergent. What's the last one? You're adding small numbers. This one, your common difference is positive 3. This one, your common difference is negative 5. This one, your common difference is 1/2, 0.5. It's not adding very much. But still, what's going to happen? It's going to be divergent because it's going to keep on expanding, and hence the infinite sum is going to be infinite. So looking up here really quickly, we see this word converges, and converges comes underneath the infinite sum does exist. What term am I going to write down really quickly off to the side for when the infinite sum does not exist, hence why or when it's infinity or negative infinity? Yeah, I'm going to write divergent, just in quick parentheses. Divergent would be an adjective. The noun would be that the sum or the series diverges. We'll just say divergent. The divergent series. Well, I guess to make it parallel with the idea below, we'll say divergence. Okay. But hold on. We need to figure out what's going on with geometric and why he's so different. You ready? What if I was to give you the following geometric? We'll come back, don't worry. Before the yellow box, I want you guys to put these quick examples. Let's do 4 plus 8 plus 16 plus 32 plus ... Let's do negative 3 plus 9 minus 27 plus 81. Then let's do, 1 second, 3/10 plus 3/100 plus 3/1000. Okay, David, what was your question?
I thought it was, I just.
Why are these three geometric? Why should you be able to label them all as geometric? Tell me a reason for number one.
R
Someone help me that real quick. Multiply by what? Oh, someone help her out. Help her out. There we go.
R is -3.
R is equal to 2, right? Times 2 times 2 times 2. I know, okay, there was 1. I knew that. Times R times R times R times R times 2 times 2 times 2 times 2. What do you guys think the infinite sum would be of this series where a sub 1 is 4 and R is equal to 2? Divergent because the sum would be infinity. 4 plus 18 plus 16 plus 32 plus 64, etc., etc., etc. Does that make sense, kind of? It's getting bigger and bigger and bigger as you add and add and add. Number 2. Negative 3 plus 9 would be a positive number, but then minus 27 would be a negative number, and then plus 81 would be a positive number. Negative 3 is my common ratio. We're looking at what happens when you have a common ratio that's a negative number now instead. Does anybody know what this sum would equal?
Divergent.
It's kind of going like bigger positive, bigger negative, bigger positive, bigger negative, bigger positive, bigger negative. This one's really hard, kind of maybe needs calculus and limits to explain. We'll just say it doesn't exist. It's going to be going back and forth, farther and farther and farther away from the x-axis if it was a graph. You can't say it's going to positive and negative infinity, but that's kind of what it's doing. So we say D and E. They don't agree. It does not exist. But still, long story short, divergent. So we've already seen that when the sum is infinite, the series is called divergent. And now we've seen, well, if it goes back and forth and can't like agree,
Convergent.
still divergent. Because it's not going to one nice answer. It's actually kind of bouncing all over the place as you keep on going. A negative ratio makes it alternate. And it's alternating in a way that's going still farther and farther and farther away from one single answer. But what makes number 3 very, very different?
It's like a logarithmic still. That's getting
The
closer
terms
and
are getting
closer to
smaller.
1.
The sum is still getting bigger, technically,
It's
but by
getting
smaller
closer
and
to
smaller and smaller and smaller and smaller steps.
It'll never hit negative.
It's not. What is
It'll
it?
never go to negative or positive infinity, but why not?
Never be 1.
Because the R is less than 1.
Okay.
Well, first of all, R is, have you guys figured out what R is?
Yeah.
110.
1/10, good. And to be honest, even if I had shown you an example with a negative 1/10 where it was bouncing back and forth, it'd be bouncing back and forth where it's actually getting closer and closer to a set number. Can I show you guys what that set number is? Wait, what? How did I know it was a set number? Alright, now people that like decimals, finally you get to have your day. It's hard to see in fractions, it's easier to think in decimals. What's 3/10 as a decimal? What's 3 hundredths? What's 3 thousandths?
Oh.
Isn't this just going to be
Yes.
0.3333?
Yeah.
Infinite sum, adding together more and more and more and more and more pieces. But what does that infinite sum converge to?
1/3.
A set number. But what was so special about this geometric series that was different than the other two? What you notice about R?
Fractions.
He's fractional, but not just any fraction. Let's go back to our notes real quick. Not just any fraction. He's a fraction such that R is in between positive and negative. No, not or equal to. Huge mistake. I apologize. He's in between, but not including positive and negative 1. If R was equal to 1, what would be going on to the pieces I'm adding together?
Stay the same.
Yeah. So if I start at 3 and R was 1, it'd be 3 plus 3 plus 3 plus 3. Is that divergent or convergent?
Divergent.
That doesn't work. So it can't work at 1 or negative 1. But if R is in between, another way of writing it, if you want to do like snazzier notation is sometimes seen as absolute value of R, so whether or not R is positive or negative if its magnitude is less than 1. Why is that so important? What if I was to give you the example of R is equal to 4/3? It's bigger than 1, so as I multiply by R, it's still going to be expanding. So that's going to be divergent. The infinite sum will be infinite. So doesn't exist when, well, basically R is anything else. Meaning R is, can I say the snazzy one? Absolute value of R is greater than or equal to 1. Or, I'll show the other notation. R is greater than or equal to 1. Or less than or equal to negative 1. So, super important, two super important ideas. If I were you, even though it's not in the yellow box specifically, I would kind of star highlight this idea, because this is when you know, I can find an infinite sum, or just say divergent. Be like, no, he doesn't exist, it doesn't work. So either, if they ask you for an infinite sum, either it will work and you can give an answer, or it won't work and you can't give an answer. So here's the idea for the formula you need to write down before we finish. If the series is convergent, right? If absolute value of R is less than 1, then S sub n with this formula will equal the infinite sum. Tomorrow we'll talk about notation and how the book, I don't like their notation, but it still will work. Bye, cool kids, I'll see you tomorrow. Section 9.3, do then. Yep. We got our final formula, you guys got this.
Not all magnitudes of infinity